Today with our notes we are defining proportional relationships and explaining how we can identify if a table, equation, graph, or situation describes a proportional or non-proportional relationship. So, we're going to start with our tables section. What does proportionality look like from a table? And the answer to that is that cross products are equal all the way down. So cross products, all of them are equal. That's the first test. And the second one would be that y over x is always the same number. And with that test, we're going to add a little statement. So y over x is always the same, but you skip the zeros. Skip zeros. And we're going to do 3 examples here so you can see what I mean. So our first test, cross products are always equal. I'm going to look at this. So I'm going to go from negative 2 5/10 times 0. And we know that that's 0. Then negative 2 times 0 is also 0. And then, since 0 equals 0, so those cross products are the same, that means that's proportional. Now let's do the next one. 0 times 2 is 0. 0 times 2 5/10, 0. Those cross products are the same, so we're still thinking it's proportional. 2 5/10 times 4 is 10, and 2 times 5 is also 10, which lets us know since each of those cross products equal the same value, we're leaning toward proportional. So we're going to go ahead and underline yes, but we're going to test out this second test option about y over x. So if I do negative 2 5/10 over negative 2, so my y value over my x value, I get positive 1 25/100. I skip the zeros, and then I'm going to do 2 5/10 divided by 2, and I still get 1 25/100. Now let's try 5 over 4. Look at that, I still get 1 25/100. Because my cross products are all equal, and my y over x is always the same, we are going to say yes, this is a proportional relationship. Now let's look at B. We're going to start with our cross products test. So if I do 17 times negative 1, I get negative 17. And then negative 3 times 7, I get negative 21. Those cross products are not the same. So let's try our y over x test and see, maybe that's just a fluke with cross products. So if I do 17 over negative 3, I get negative 4.6 repeating. I'm going to skip my 0, 2 value, and I'm going to try 7 over negative 1. Well, I get negative 7. Negative 4.6 repeating is not the same as negative 7. Our cross products are not equal as well, so this is not proportional. So now let's look at C. When I do my cross products, negative 11 25/100 times 0 is 0. Negative 5 times 0 is 0. That checks out. 0 times 3 is 0. 0 times 6 75/100, 0. Then when I look at 6 75/100 times 4, I get 27. And when I do 3 times 9, I also get 27. So I'm leaning toward this being yes, it's proportional. But let's check our y over x values. So if I have negative 11 25/100 over negative 5, that becomes 2 25/100. And you can just put these in the calculator. You do not have to calculate them yourself. I skip the zeros, so I'm going to then go to 6 75/100 divided by 3, which also is the same as 2 25/100. And then finally, let's test 9 over 4. and that is also 2 and 2500. So it is safe to say, yes, that is a proportional relationship. So those are our two tests for looking for proportionality in a table. You're going to make sure all cross products are equal, and then you're going to look at the y over x values, and if it's always the same number, then it's safe to say that relationship is proportional. Now let's look at equations. Proportionality in an equation is going to look like y equals mx. What that means, if that's what the equation looks like, that means our y-intercept is 0. So y-intercept equals 0. Or you are only multiplying. Another way to think about this is that it is not y equals mx plus b. It is just y equals mx. So if you see y equals mx plus b, not proportional. There is no adding or subtracting a number. So let's look at these examples. On A, I have 1 over 16 times x. I am not adding or subtracting a number. There is no plus b. It's just y equals mx. So yes, A is proportional. If I look at B, this says y equals 2x plus 1x, so we need to combine like terms. 2x plus 1x is the same as y equals 3x. So I'm still just multiplying. I'm not adding or subtracting any numbers. So that is also proportional. If I look at C, it says 1/2 x plus 8. This plus 8, I am adding a number, so it is not proportional. There is a b value that is not 0, so it is not proportional. And then D, same problem, it has a y-intercept of 3, so it is also not proportional. So when we are looking at an equation, you are just looking for an equation that says y equals mx, because our y-intercept is 0 if it is proportional. Now let's talk about proportionality on a graph. So in a graph, proportionality looks like a straight line and it goes through the origin. So we're looking for straight lines that go through origin, and the ordered pair for the origin is 0, 0. So again, we're seeing that our y-intercept is 0. So if I look at A, I know it's really small on your paper. I'm going to zoom in here. My y-intercept is at 0, 0, and it is a straight line. So we can say safely, yes, that is a proportional relationship. For B, my digital copy did not save this image, but it is a parabola or something that looks like that. So it is not a straight line. And if you notice, it goes through the y-intercept at -3. So on both of our rules, a straight line and it goes through the origin, that is false. So it is not proportional. And then we look at C. Again, I'm going to zoom in here. My y-intercept is +2. So even though it's a straight line, I have to write no because it does not go through the origin at 0, 0. So that's how we use tables, equations, and graphs to look at proportionality. Now we're going to talk about verbal description. So what does proportionality look like in verbal form? In verbal form, it is only multiplication. So in verbal form, it is a phrase or situation that implies only multiplication happening. So that means there are no fees or constants. No fees or constants in our word problems. So let's look at these examples. For A, it says bananas cost $3 per pound. The only key word that indicates an operation here is per, and we know that means multiplication. So that would be y equals 3x. I'm not adding anything, I am only multiplying, so yes, that is proportional. For B, it says a plumber charges $30 per hour and a $50 service fee. So our words that indicate operations here, per and the word and. So this tells us multiplication, which is good, but this tells us to add. And it even says fee, and we know that proportional situations do not have fees. So this is not proportional. So let's look at C now. Joe buys pencils for 50 cents each. Each indicates our multiplication there. And an eraser for $1.50. So if we were looking for his total cost, we would have to add that $1.50. We do not want to add $1.50, we just want to multiply, so this is not a proportional relationship. And then finally, Kate earns $12 an hour babysitting. So $12 an hour, it lets us know that our rate is 12. There's no constant, there are no additional fees being added or subtracted. So yes, this is proportional because we are just multiplying. All right, part 5 and the other problems we will do in class tomorrow before you get to do your group work activity. So please make sure that your notes have all of these portions. We will talk through part 5, so please do not work on it right now. Just go ahead and put it in your binder in your Unit 4 section, and have a great day.